Hello YouTube and welcome to my channel. I haven't made an electronics video in quite a while. So I figured, well, let's show you something in regards to digital electronics. I was online looking at schematics of they're called 4-line to 2-line encoders. And there's a bunch of variations as far as like how to make that circuit using different types of logical gate ICs, you know, that between ands or ors or nors, however they're doing it. I noticed that, like I said, a bunch of different ways to inflate the same wheel. You know what I mean? So I came up with a simple diode, 4-diode encoder, which works just as good as all the gates. Here's the schematic right here. So here's our 4 lines in, if you can see that, and then the encoded 2 lines out. And yeah, it's just using 4 diodes. So these the one is the least significant bit all the way up to the most significant bit, and same thing down here, least significant bit, most significant bit. All right. The truth table of this device looks like this. The input, like you said, you have 4 lines of input. When you have, you see how this one keeps trailing, each place. And the encoder, again, when there's just a 1 there, it puts out a 0. When you have a 10 here, if you want to call it a 10, it puts out a 10 there. Or no, I'm sorry. When you have a 10 here, it puts out a 1. When you have 100 here, it puts out a 10. You can say it like that. And you have a 1,000 here, it puts out 11. If you want to say it that way. But yeah, so you can see it has four different encodings on these 4 different bit positions that are lit up with a 1. As far as the rest of these bits go, it won't matter to the encoder. It just these 4 bits are the ones that really matter. Beyond that, the encoder don't care about the output. Now, to demonstrate that to you, I already built it on my kit here for you. I have my 4 input bits right here with these LEDs, and over here these 2 LEDs are going to be the encoded output bit. So when I hit the least significant bit, see it lights that 1 LED up. But you notice nothing lights up over here on the encoder output. It's nothing. Now, bit 2 lights the encoded bit 1. Line 3 lights up the encoded bit 2. And line 4 outputs to both, that makes both encodes 1 and 2 bits are both lit. So that's basically how the encoder works. See, bit 1, bit 2, bit 3, bit 4. Just like that. It's encoding. It's taking 4 lines and encoding them into 2 lines. The decoding process is a lot more complicated. You can't do that with diodes. You actually have to use some... I was trying to draw a couple schematics of my own design here to try and figure that out. I came up with one, but it uses like 4 different gates. I'm using like 2, I think I'm using 2 AND gates. And yeah, I came up with a way by using 2 AND gates and 2 inverters to decode that encoded, I don't even know what's on this paper here, to be honest with you. I know I wrote it down here somewhere. Oh, here it is. Here's when I first started playing around with it right here, down at the bottom. Yeah, I'm actually using 3 AND gates, 2 inverters, and 1 NOR gate to decode the 2 lines back into the 4 line. If you can see that. That's what I came up with. Yeah, and here's the encoder here, in another form of it. But just another quick topic. Like I said, I was using diodes. The diode was invented in 1874 by, if I'm saying it the right way, Ferdinand Braun. was a German scientist. He's the one who's credited with discovering the diode. So, well, that's it for my video. Thanks for coming along. Thanks for watching. Please subscribe, and we'll see us all again later. Bye-bye.